Okay, today we are going to be determining the end behavior of polynomial graphs. Determining end behavior of polynomial graphs. And an example of the end behavior of a polynomial graph is, let's say we've got a graph that looks something like this. This is a graph of y equals 4x to the fourth plus 6x to the third minus x. What determines the end behavior of the graph is this leading coefficient and the power that it's raised to. Okay? This graph, end behavior, this graph's end behavior is called up and up. Simply because starting on the left-hand side of the graph and moving across to the right, the left-hand side of the graph is going up, and the right-hand side of the graph is going up. So if you are asked to determine the end behavior of this graph, you would call it up and up. If we took another graph and it was basically a parabola but going down, this is a graph of y equals negative x squared plus 2x. And if we were describing or determining the end behavior of this graph, we start on the left. We got it going down and moving from left to right, down. Okay, so the end behavior is down and down. All right, this graph is the graph of y equals x to the third. If we were describing its end behavior, starting on the left, moving to the right, this is down and up. End behavior is down and up. All right, and then finally, we've got this graph. And this graph is of y equals negative x to the fourth plus 2x. If we are describing the end behavior, again, we start on the left-hand side of the graph. We're going up. And moving to the right side of the graph, we're going down. So the description of this graph would be up and down. Everybody okay with that? Looking at the graph, describing the end behavior of the graph. Now, the end behavior of the graph is determined by the leading coefficient. The leading coefficient is, when the graph is in standard form, the term that has the highest power. All right? So end behavior is determined by the leading coefficient in standard form. And I'm going to give you a table that you can use based on y equal to ax to the nth power, being the leading coefficient, n being the highest power in the function, and a being the term in front of the variable. So we're going to say that when a is positive, and n is even. When a is positive and n is even, we got up and up. When our a is positive and our n is odd, the end behavior will be down and up. You can continue this table. Right here, we're going to go when a is negative. When a is negative. When our a is negative. When a is negative and n is even, we got down and down. And then finally, when our A is negative and our N is odd, we got up and down. So all you're going to be doing today is you're going to be asked to determine the end behavior of the graph. You're going to be given the graph or the equation in all different formats. The key is that you identify the leading coefficient. The leading coefficient is the term to the highest degree, or the term to the highest exponent. So if you were asked to determine the end behavior of something like y is equal to 6x minus 3x to the fourth plus 4x to the fifth. Ideally, you would write this in standard form, but you don't need to. What you need to do is identify what the leading coefficient would be. The leading coefficient would be the term with the highest degree or power. So here is our leading coefficient if we wrote it in standard form. Our A is positive and our N is odd. So when A is positive and N is odd, we got down and up. So our end behavior would be down and up. So identify the term raised to the highest power. Look at its A value, which is in front of the variable, and look at the exponent. And then use this little chart that we just assembled. Okay, so if we got y is equal to 5 minus 4x to the 7th plus 8x to the 8th minus 9x to the 10th. Our highest power is this negative 9x to the 10th. In this term, our A is negative. Our N is even. So when our A is negative and our N is even, the end behavior is down and down. Everybody get the idea? Find the term with the highest power and then look at its A value and look at the odd or evenness of the exponent. Take that information, apply it to the chart, and the chart will tell you the end behavior of the graph. So let's do one more. Let's do y is equal to 6x to the third minus 2x squared plus x minus 5. All right, this happens to be in standard form. And the term with the highest power is listed first. So that's our leading coefficient. Our A is positive and our N is odd. So when A is positive and N is odd, we got end behavior that is down and up. Everybody okay with that? All right, your practice is on page 285 today. problems are going to be 20 through 31. I'm going to not touch this screen because I don't know what will happen if I do. Can I finish first?